Alright, we're going to go ahead and review. This is a parallelogram. We're going to list its properties, an example of each property using the diagram, okay, of the figure. So one of the first properties of a parallelogram is opposite sides are parallel. I'm abbreviating a little bit just so I have room. Okay, you could list any pair of opposite sides. So for example, you could say BC and AD were parallel, or you could say AB and DC are parallel. I'm going to use those two. To write it in the right kind of math example, we write segment AB is parallel to segment DC. Be careful on this one because a lot of you guys on the test, instead of parallel, you wrote congruent, which was wrong. Okay, so make sure when you're saying the opposite sides are parallel, you use the parallel sign symbols. Okay, next property of a parallelogram, opposite sides are congruent. One of the things you guys also did wrong on the test was a lot of you didn't include the word opposite. You just put sides are congruent, okay? And that's not true. Not all the sides of the parallelogram are congruent to each other. Is AB the same size as AD? No, it's not. So you have to include those words like opposite, be specific, okay? So if the opposite sides are congruent, you could pick any pair of opposite sides. I'll just pick AB and DC are opposite sides, okay? So I'm going to say that AB is congruent to DC as my example. Alright, for our next property, I'm going to go with opposite angles are congruent. Okay, I could pick any set of opposite angles. Let's say, for example, I pick A and C. I could use those are congruent. Okay, or I can use B and D. Okay, I'll go ahead and use B and D. So angle B is congruent to angle D. Okay, next. Okay, consecutive angles. And a lot of you guys kind of messed this one up on the test because you just put some other word other than consecutive. Okay, like a lot of you put corresponding, which is not correct. All right, so consecutive angles are, we don't say congruent because they are not congruent. Look at angle A and look at angle B. They are definitely not the same size. Okay, but what they are is they are supplementary. Okay, now to write that, I would say the measure of angle A added with the measure of angle B equals 180 degrees. That's an example of two consecutive angles being supplementary in this figure. Okay, last property is that diagonals bisect each other. A lot of you guys wrote down for this property diagonals bisect. If you just say diagonals bisect, I don't know what they're bisecting. You have to tell me that they bisect each other. Okay, so diagonals bisect each other. It's really important that you put each other. Okay, now an example of this would be when the diagonals are bisected, that their parts, like BE, ends up being the same size as ED. Okay, so we could say, for example, that BE is congruent to DE. That would be an example of how that diagonal is being cut in half.